Hello all, my name is Abdurrahman and welcome back to my YouTube channel. In this video today we are going to talk about the big O notations like what it is, how it works, why it's used, etc. If you remember guys, in the last video we talked about the time complexity, space complexity, and before that we also talked about the time complexity and the frequency count method. Basically guys, what happened here is that I specifically talked about this space complexity. I also talked about the time complexity but not in detail. So in the video frequency count method, I talked about time complexity and I have worked with an algorithm where we will be finding the time taken by an algorithm. But here the reason that I am bringing the topic of big O notations like what it is, how it works, is that while finding the time taken by an algorithm, the very much important thing is big O notations. So big O notations is a big part in finding the time complexity. So that's why we are going to talk about the big O notations, and later on I will try to make a video on time complexity where we will be working with an example. So let's begin. First of all, let's talk about what is big O notations. Big O notation is a way to describe how fast an algorithm grows with the size of the input. Now basically guys, while finding the time complexity we use some of the things and we can find that, but when the algorithm is changing each and every time we have to do that. But with the big notations, what we can do is it's a way to describe how fast an algorithm grows with the size of the input. Now if we talk about that in the simple words, then let's say you have an algorithm to search for a number in the list. Let's say for example I have a large list. For example here we have something called as list, okay, which is equal to 1, sorry, this which is equal to 1 2 3 4 5 6 7 8 9 and 10. Let's give it just till 10 and it's infinite. Let's say we have a list. Now what we have to do is, if we have an algorithm to search for a number in a list, now by algorithm I mean is Python, a program. Now whether it can be any program, whether it can be C program, Python program, any program, but here I'm going to talk with the Python program because I have worked with the Python itself. So anyhow, now if we have a Python program and algorithm to search for a number in a list, if the list has only a few numbers, let's say we don't have any infinite numbers, that we just have till 10, the algorithm might be very fast. Okay, now if I ask you that I have a list something called as 1 2 3 4 5 6 7 8 9 10. Okay, I have this one, but if I say that find the number 6, find the number 6, what you will do, you will see that at which point it is, you will count and 1 2 3 4, so 6 is going to be here, you will say. But if I ask you to find that what is like 1 2, if I say that find the 3 and 8, now you will go in this way, we have 3 and 8, you can find it easily. But here what I will do is I will remove everything, so this is not needed right now. Now I will be creating another list called as something called as 3 2 4 9, any number, random numbers like 1 6 5 8 3 and 10, let's say. Okay, so we have these numbers. Now if I say that find the number 1 or 9, any, let's say 4, let's say 8. Okay, what will you do, you will search like this, like 1 2 3, you think that it's in the ascending or descending order, but it's not there, it's in the random format. What you will do, you will search for 8, so you have found the 8, so 8 is here. Now if I ask you to find 9 also, you will find that here by searching 2 4 9. Okay, so here we have the 9 and 165. Okay, here I have the 8, so you can find it easily. If I have given the random numbers, if I have given that plain, you can say that here, oh, here I have that one. But here if I give you infinite numbers, let's say more than lakhs and crores of numbers, what will you do with that? If I say find some number, only a number, you will go in that way, it will be some easy to find that. But if I say find 5 numbers like this number and this number, it's going to be pretty much fast, right? So from those crores of numbers, if I say that find this number, let's say five numbers, any random numbers, what you will do is you are going to search for. Now it's not like 1, 2, 3, 4. It's in the digits, more than three digits, four digits, etc. So it's going to be in crores, right? So it's going to take a lot and a lot of time, right? How will you do that? So like that for algorithms also, it might takes longer to find that number, that specific number. But here big O notation helps you to describe the efficiency of the algorithm by expressing how many operations the algorithm performs as the size of the input grows. For example, if I give you around 100 crores of numbers, and if I say that find the 10 numbers from that, from find the specific 10 numbers from that, what will you do? It's going to take a lot of time to find that, right? But if I give you another person which is going to help you to count five numbers, only five numbers, not 10, so it will be some easy. If I give you another number, then it's going to be some more easy. If I give you 10 numbers, you have to just find the one number. Like that also, big notations helps you to describe the efficiency of the algorithm by expressing how many operations the algorithm performs as the size of the input grows. Now with the number of infinite numbers, what we will do? So the input is growing obviously. Right? For example, if you take the algorithm that takes order of n, for example, if I show you that here, let's go somewhere down. So okay, if you take some algorithm that takes big order of n, okay, order of 10 of the time, not this is, I'm not just calling it as the degree. So if I talk about the time, then that means the algorithms takes roughly a number of steps to complete that, where n is the size of the input. Now here if I give the value of n is the size, any size, just dash, let's give it a dash. Now n is the number of steps, so it's going to take the roughly steps. The algorithm is going to take the roughly n steps to complete, where n is the size of the input, as I said. If the input size doubles, the algorithm takes roughly twice as many steps to complete. For example, if I have the 100 steps to take, this is just an example, or let's give 50 only, 50. Now here it's going to take the 50 steps, but randomly roughly it's going to take. But here when the algorithm, when the n size increase, it's going to, what it's going to do is it's going to double it, which is going to be 100, right? So it's going to double, and the algorithm takes the roughly twice as many steps to complete. If I talk about that in the summary, then big notation is a tool that helps you to evaluate how fast an algorithm grows with the input size. It helps you to compare different algorithms and choose the most efficient one for a particular problem. Okay, now for example, as I given the example of this one here, where we have some random numbers, crores of numbers, unlimited numbers. Now if I said say that find the 10 numbers from that, okay, now you can find that, but it's going to take some more time. And one more thing is that I have not arranged the numbers, those infinite numbers, I have given them randomly, so it's going to take a lot of time for you. Now if I give you a person for that, what he will do, it's going to find the, it's going to help you to find those numbers. Now what if I give you a person who is going to find the six numbers from what you're finding, right? So it will be very very much helpful for you. But if I give you, in place of that person, if I give you a person who can just find the two numbers, so it's not going to be correct, right? So I will be keeping 10%. Example, this is, I will be keeping 10% who can find the numbers more and very easily some time, in small time. Okay, so I will choose a person, A, B, C, D, from all of them. I will choose the B. So it's going to find. So like that, big notation is going to do that same thing. Big notation is a tool that helps you to evaluate how fast an algorithm grows with the input size. It helps you to compare different algorithms and choose the most efficient one, as we are choosing the most efficient person for a particular problem, for the problem of selecting these numbers. This is just an example. So that is what the big O rotations. So anyhow guys, that's all for this video, and I hope you liked this video and enjoyed watching this video. And in the next video I'm going to explain the big O rotations with an example, and I'm going to implement this with the Python program. So thank you all for watching this video and goodbye.